Hello everyone, welcome to 1045 Engineering. We are here with yet another video in our Grind 75, a Better Blind 75 coding series. So, today's problem is on validating binary search tree. It is actually very simple. We just have to check that the left node value is smaller than the root and the right node's value is bigger than the root value. And similarly, we have to recursively verify that the left and the right subtrees are binary search tree as well. Okay. So let's jump into the problem statement. Last time we have solved the min stack. You can find it in the list. Let's start with validate binary search tree. Okay. Given the root of a binary tree, determine if a valid binary search tree. Okay. If it is a valid binary search tree is defined as follows. The left subtree of a node contains only nodes with keys less than the node's key. Okay. So this is a root 2. The left child will have its value lesser than the root value. The right subtree of a node contains only nodes with keys greater than the node's key. So on the right side, child value 3 would be greater than the root's value, which is 2, right? Similarly, we can say yes, this is a binary search tree. If we check for this one, we have 1 5 4, and then 4 has 6 and 3, right? Now this is not a binary search tree, okay, because root node's value is 5 but its right child value is 4. This is smaller than this 5, right? So what we have to do is we have to verify that this is a binary search tree. So this node is bigger than the left node, smaller than the right node. And then recursively, the left subtree is also a binary search tree and right subtree is also a binary search tree. Now, considering we have solved a lot of problems on binary search tree in our Grind 75 list, this is a very easy problem. We just have to put the logic and it will be all simple. Okay. Now, so what I'm going to do is we are going to check for the node value to be between the left side and the right side. And then recursively we will call the same binary search tree validation method and we'll pass the left subtree and the right subtree. Now for the beginning, to compare the node alone, we'll initialize two values for the minimum and the maximum. Okay, and other when we go for the left and right subtrees, we'll pass the maximum value for right subtree as the root value. We'll pass the minimum value for the right subtree as the root value. Okay, let's start. Um, okay, I'll create a helper method. Okay, from this one I'll not call. I'll create a helper method, private boolean, private boolean is valid binary search tree helper method, right? Helper. We'll pass our node, tree node. Similarly, we'll have our min value and the max value. Long min value and long max value. Now why am I going for long here? So generally we always go with int, right? Why are we going for long? Because the logic that I am taking is the one where I will be giving the initial smallest integer value and the largest integer value. Now there could be a case that the node value is same as the smallest integer possible value, so that in order to avoid that edge case, we'll pass the smallest long value and the largest long value, so they'll always be bigger than the integer value in the range. They have already given us the range. Okay, so let me clarify here. We are going to call this method like this: return is valid bst helper. Will pass root, and generally we pass integer dot min value and integer dot max value. But then we'll have certain edge cases that the root value is same as the min value, integer dot min value, right? That's why in order to avoid those edge cases, we'll go with long. Okay, let me comment it as well. Okay, so use long dot min value and long dot max value to handle edge cases with integer dot min value and the integer dot max value. Okay, now so now what we are going to do now is, now we have called this method, we are just going to check. First would be a base case, what if the root is null, right? So base case, check for null, right? So we can say if node is equal to null, return true. Plus this will be used for the child nodes as well. Now simply I am going to compare the nodes value with the left and the right, if they are in the range or not. For the first one, 2, we have already passed the values as min value and the max value, right? So we'll say or I'll comment, check if the current nodes value is within the range. Okay, so we'll check if node dot val, we have this variable as well. So if node dot val is less than equal to min value, that is long dot min value. Okay, and similarly node dot val is greater than equal to max value, so we'll say max value. Okay, now do I have some extra? Okay, yeah, if it so happens, that means our value that we have given is smaller than our min value or it is greater than our max value, that means it is outside range, right? So we can simply return false. Otherwise we'll recursively call the same method for the left subtree and the right subtree. Now we'll say or let me comment, recursively check the left and right subtrees, right? So we can say return is valid BST, helper will pass node dot left, okay, then min value, and then instead of the max value for this left hand side subtree will pass this current node's value, so that will be node dot val. And why and? Because the left subtree has to be a BST, right subtree has to be a BST, only then this is a BST, right? So similarly we'll check is valid BST helper, okay, it's going outside, okay, is valid BST helper, we'll say node dot right, instead of min value now it will be node dot val and max value, right? Because for the right side its minimum value has to be the node's value, right? So we pass node dot val as min value and the max value, and that's it. We'll run it, we'll check, and that is the end of the code. Oops, somewhere something is failing. Min value, line number 34, VALUE, run. Okay, let's see, yeah, it's working fine. Let's submit. So I think everyone would have used the same approach most likely. So we may be, oh okay, our time complexity is running way too good, beats 100% of the users with Java, though this is the most basic approach that should be used for this solution. I'm not sure if people have used some other approaches as well, but yeah, that's it. Okay, so that's it from today's video, everyone. For anything, please let me know in the comment section, and in the end, please like, share and subscribe. Thank you.